All right, arithmetic sequences, recursive and explicit. There are the formulas for each. We did the notes. If you missed the notes, you should go watch the notes. Here we go with the assignment, though. Write the next three terms of the arithmetic sequence. All right, so this is plus 7, plus 7, plus 7. So our common difference, CD, is 7, and we can also just call it D. Anyway, we really don't need to define that. I'm just doing it because that's part of an arithmetic sequence. So we have 29, 36, and 43. And then describe the pattern. Well, I did. It's there. All right. We have minus 6, minus 6, minus 6. So that's the pattern. And the next three terms are going to be negative 4, negative 10, negative 16. We have plus 9, plus 9, plus 9. That's our pattern, is plus 9. The next three terms, we got 48, 57, 66. We are doing plus 7, plus 7, plus 7. So we get 33, 40, and 47. For number 5, we're adding 4, we're adding 4, we're adding 4. That's our pattern. We have 19, 23, and 27. We are adding 12, adding 12, adding 12. That's the pattern. We get 50, 62, 74. So if you're like, that seems real easy, well, that's fine. Now here we go with graphing the arithmetic sequence. The first term is 1, so I'm going to call this 1, 1. The second term is 3. The third term is 5, and the fourth term is 7. So if you're like, well, how was I supposed to know that? Well, we did talk about it way up here, that this is like slope-intercept form, and that we don't technically have a y-intercept here, but we could figure that out, okay? But let me get my little drawing tool and let's graph this thing. It's gonna go through like that. The slope is 2. So it won't go through 0, 0, but it'll be real close, right? So there is the graph of this thing. The next one, 1, 9. So I'm just assuming this is a 10 by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, it is. So the first term, 1, 9, 2, 6, 3, 3, 3, 0. And now let's get our graph on like that. Okay, we got a little bit of fraction action here. And if you're like, I'm not really good at fractions, well, yeah, you could do this. Just, if you need to, grab a calculator. This is 7.5. This is, let's see, 6.5, 5.5, 4.5, right? And how much are we changing by each time? We're changing by 2 over 2. So really, here's 10, 9, 8, 7. So here's 7.5. And essentially what we're doing is we're going down to, oh, that blue is for some reason really tiny. We're going down 2 over 2, like that. And if you're like, well, but why did you do that? Well, I mean, that is our slope, right? And if you think about it, this is 3, and the third term is 5.5, and that's 5.5. Anyway, and then, but yes, we're going down by, we're really going down 1 over 1 each time, so that's what it looks like. And since we are going down 1 over 1, we can tell you that that's the y-intercept right there. I'm really kind of giving you a whole lot more than you really need on this problem. But there we go. There's the graph. Next, to determine whether the graph represents an arithmetic sequence. I'm pretty sure I can go ahead and tell you no, because that has a slope of up 1 over 1. This has a slope of up 3 over 1. And this has a slope of, let's see, up 5 over 1. So our first term was 0. Our second term was 1. Our third term was 4. and our fourth term is 9. So if you're like, why is he pointing out the slopes? Because this was plus 1, this was plus 3, so 1, 3, and this was plus 5. So for this, the slopes is a reason why it's not arithmetic. This is why it's not arithmetic, because it needs to have a common difference. The common difference would be that it would be, they're all the same, like they go up 7, 7, 7, or 4, 4, 4. Okay, this one, I can go ahead and tell you, this is arithmetic. We are going up 10 over 1, up 10 over 1, up 10 over 1. So yes, this one does. So here, let's make it crystal clear. No, yes. And let's see, we're going down 3 over 1, down 3 over 1, down 3 over 1. And I'm also like doing the math right there of 21 minus 3 is 18, 18 minus 3 is 15, and so on. So this one is also yes. And to just reiterate it, it's because these two have a common difference and this guy does not. So for this part, we're supposed to write an equation for the nth term of the arithmetic sequence, then find a sub 10. So here's a reminder, recursive formula looks like this, explicit formula looks like this. Which one do you think is the one you should use on this part? Well, I've jumped up here on the notes to kind of give the notes opinion of this thing. So the notes say, hey, listen, you should use the recursive formula when you're trying to find the next term depending on the previous term. And you should use the explicit formula for any term depending on the term number. So in my mind, this is the winner. That's the one we're going to use is explicit. So if you chose to write it like this, then the first thing you would need to do is realize you wrote a sub 1 right here and not a sub n minus 1. So let me sneak that back in there, n minus 1. So if you were going to do this, for here you'd need the 9th term before you could find the 10th term, and that's just not something I'm interested in doing. So to reiterate, this is what I'm interested in doing. Okay, so a sub n is going to equal, what do we say again? The first term, so negative 5.4 plus the common difference times n minus 1. Okay, so what's our common difference? Well, looks like we have gone down by 1.2, down by 1.2, down by 1.2. So again, our a sub n equals negative 5.4 minus 1.2 times n minus 1. And I'm going to erase this just so I can have some more room to write. Now to find the 10th term. So a sub 10 equals negative 5.4 minus 1.2 times 9. We get that a sub 10 equals negative 16.2. So 2 answers for this problem. There they are. Number 14, a sub n equals 48, because that's the first term, plus, actually, I'm going to do minus 10 times n minus 1. If you're wondering how I'm getting that, it's this, okay? We have our first term, our common difference, and this part doesn't really change. And now, to find the 10th term, we say a sub 10 equals 48 minus 10 times 9. We get negative 42. So, one answer and the other. A sub n equals 6 plus 4 times n minus 1. Why is it plus this time? Because we're going up by 4 each time. And I guess did I write that over here? Not really, but I think you could kind of tell that we're subtracting by, hold up. I think there might be a typo on this one, because this is a difference of 10, this is a difference of 5. And so is that. Huh. So, this is not an arithmetic sequence. I think that's just a boo-boo. that maybe they were meant to have gone down by 5 each time. So, you know what, why don't I just do this problem as if it was meant to go down by 5 as well, just for fun. So let's pretend it was supposed to have been going down, or it was going down by 5. Well, then it looks like that. And then to find the 10th term, it's, the 10th term, this would still be 9, because 10 minus 1. So 48 minus 45 would just be 3. So there's the other possible answer. Don't overthink this one. I think really it must have just been a typo. Going here, though, this is plus 4 each time. And this is the right sequence for it, or the right formula for it. Now to find a sub 10 is 6 plus 4 times 9. That's 36 plus 6, so a sub 10 is 42. There's this answer and this answer. And we're going down by 2. No, we're going up by 2. We're going up by 2. We're going up by 2. A sub n equals negative 11 plus 2 times n minus 1. Again, if you're a little lost on how I'm doing that, it's this, okay? And if you're like, why are we not doing this? Because this one would require me to have to find the first 9 terms, or really just the 9th term, before I could do the 10th term. All right, so a sub 10 equals negative 11 plus 2 times 9. Why is it 9? Because 10 minus 1. Negative 11 plus 18 is 7. So there's one and the other. We're going up 3 each time. So a sub n equals 3. Just kidding. Equals 34 plus 3 times n minus 1. A sub 10 equals 34 plus 3 times 9. So 34. Let's see, 34 plus 27 is 61. 18. We're going up by, down by 2. Down 2, down 2, down 2. So we have a sub n equals 48 minus 2 times n minus 1. A sub 10 equals 48 minus 2 times 9. That's 48 minus 18. That's 30. Okay. And now to shake things up a little bit, we have a word problem. In an auditorium, there we go. The first row of seats has 30 seats, so row 1, we got 30. Each row behind the first row has 4 more seats. We got row 2 has 34. So I'm going to guess row 3 has 38, and so on. We want to know how many seats are in row 25. Well, so we start off with 30. We add 4 each time, and we want to know the 25th. So we'll do it like this. 25 minus 1. A sub 25 equals 30 plus 4 times 24. Well, I believe that's 96. So 96 plus 3 is 126. There we go.